Hello students, there were like two problems I gave it as a homework. Let us do the verification of our answer. The first question, as I told you people that it was 2015 annual paper question. Let me read the question. Calculate the equilibrium constant of the reaction at 298 Kelvin. There is a chemical equation given. Along with that, they are giving you the hint of E naught of the cell 3.16 volt. So let me solve it here. Let me write the data. Equilibrium constant K I want to calculate. E naught of the cell is given. Let me write it. That is 3.16 volt. Let me write even the chemical equation which is happening in the cell. Okay, I finished writing. Yeah. So let me first write Nernst equation for the cell reaction. I told you people that never ever go for by hearting expression. Always you derive it. So let us derive it. E cell equal to E naught cell minus 0.059 divided by n log to the base 10 product side divided by reactant side. Stoichiometric coefficient, I have a habit of writing it so as a power. We got it as a habit. I know that I am talking now about equilibrium. At equilibrium, no reaction is happening. Why it is not happening? Because cell potential is 0 volt. In the standard condition, reaction is happening. Because reaction is happening, it is not 0. Minus 0.059 divided by n, numerator plus 2, denominator plus 2, so the value of n must be 2. Log to the base 10, everybody knows that at equilibrium, no reaction is happening, ion concentration is not changing, so that these ions concentration ratio remains constant is K. Fine. Now, this negative term, let me take it another side, a negative term become positive term. So 0.059 divided by 2 log K to the base 10. E naught of the cell I know, so I can substitute now. 3.16, let me substitute. It will comes here to the numerator. It will go to the denominator. That is equal to log K to the base 10. I want to calculate K, right? So let me isolate it one side. Okay. Let me write the next step over here. So let me simplify this. The answer is equal to log K to the base 10. So let me take calculator. Okay, let me take calculator. So let me take values. 3.16 into 2 divided by 0.059. So the answer I am getting here, log K to the base 10, the value 107.1186. Fine. Now you want to calculate the value of K, so you are shifting this log another side. Log becomes anti-log. So we have anti-log 107.1186. So K is equal to, let me tell you a very important fact here. Why I am doing that, let me explain it little later. Now see this, whenever you want to find out the anti-log value, before the decimal point, whatever value is there, that value become power of 10. So your answer now is present in 10 to the power 107. Always what you do is, whenever you are finding out antilog of something, that 10 to the power answer you write in the beginning itself, because I have seen you people are forgetting writing this power value. Fine. So if it is like antilog of 14 point something, Your answer is in 10 to the power 14. So before the decimal point, whatever value is there, that value become power of 10 whenever you see the antilog values. Now I should see antilog table. Okay. Now look at here, we dealt with this. Now we are looking at this. What we should do now, we should open the antilog table. Look at in the antilog table, row 0.11, row 0.11, in that column 8. If you see in the antilog table 0.11 row, 8th column, the value written is 1312. Now in the same row, you go for a mean difference column, the sub column you can see. In there, you have to see the sub column 6, the value given there is 2. Understood? So 0.11 row, 8th column, 1312 given. Sub column 6 you go for, 2 is given there. What you do now? Add them up. Now whatever answer you get right, you write it. After writing final value, you are going to locate the decimal point after the first digit. So done. So whenever you will get this kind of situation where you have to see the antilog table, before the decimal point whatever value is there, that value become power of 10. Now you will see antilog table and you will find out the value where you are locating decimal point always after the first digit. I'll tell you why so. Now everybody knows that log and antilog are complementary functions of each other. Log and antilogs are the complementary functions of each other. So log value of this, okay, equal to something. So the antilog of that something will gives you this answer. Let me tell you. Antilog of this, you got this right. So log of this, you must get this. So antilog and log are complementary functions. They are reverse functions of each other. Antilog of something, you got the answer. So log of this, you should get back this. So let me see here. 1.314 into 10 to the power 107. Let me see log of this. Everyone knows that log of A into B is log A plus log B. Of course, base 10. Everybody knows that log 10 to the power x to the base 10 is x. Similarly, log 10 to the power 107 to the base 10 is 107. Correct? Now, log of this value before the decimal point, there is a 1 digit, 1 minus 1, characteristic becomes 0, 0 point something. When you add up these two, you will get this. That's it. This is a logic I am using to say that before the decimal point, whatever value is there, that should become power of 10. And after writing the final value, always you locate the decimal point after the first digit. Fine. So let me go for a second question now. Let me clear it out. So I'm reading question number 2 now. It is in text. Calculate the equilibrium constant for the reaction. Let me write the reaction. Copper to silver ion, that is giving you copper ion plus 2 Ag. Standard cell potential value also given in the question itself. It's 0.46 volt. So as I told you people that never ever go for a direct expression. You start always with the Nernst equation. So the Nernst equation says that cell potential is equal to standard cell potential minus 0.059 divided by n log to the base 10 always product side by reactant side. Stoichiometric coefficient has to be taken as the power. Concentration of the solid is always 1, so I am ignoring them. Now I am talking about equilibrium condition. Cell potential is 0 volt. is equal to E naught of the cell minus 0.059 divided by n. Look at the numerator plus 2, denominator plus 2. So the value of n must be 2. Log to the base 10, equilibrium condition, no reaction happening, ion concentration, its ratio remains constant. Negative term, bring it another side. So negative become positive. So we get the expression E naught cell is equal to 0.059 by 2 log k to the base 10. Let us have a substitution now. E naught cell is given in the question 0.46 volts. So let me write it. Is equal to, let me simplify it, 0.0. 2 2s are 4, 1 remains, 2 9s are 18, 1 remains, 2 5s are 10. Log k to the base 10. So let me go further here itself. Let me come this way. I want to find out log k to the base 10 first. Let me take this another side. So it is going to denominator. It is 0.46 divided by 0.0295. Okay, look at simplification part of this. 0.46 divided by 0.0295. So let us take calculator and let us simplify it. 0.46 divided by 0.0295, and the answer that you get 15.5932. 15.5932. What I'm doing is I'm writing this as it is first. Let me take it to another side where log become anti-log. So anti-log of 15.5932. Please see here, as I told you people that before the decimal point, whatever digit is there, that digit or the value become power of 10. The value become power of 10. Now I should see row 0.59. In the row 0.59, I should see column 3, value written 3908. In the same row, I should see the subcolumn 2, the value written is 2. Add them up, you will get 3910. As I told you people that after writing value, you are going to locate the decimal point after the first digit. So the value of equilibrium constant K is 3.910 into 10 to the power 15. That's it. Thank you.